import. That's the one. Okay, so we don't do that. Click import. And the same thing. I need to do what? Home button and file default. Button. Yeah. So I don't want to see IDs, that's right. Okay, let's make a well sketch quickly, just quickly on the well sketch. Just click on the well sketch.
Come I got three zone.
Hmm?
I got three perf.
Yeah, that's good.
You got only two perf, right?
One is below.
Oh, below. Okay.
So yeah, well sketch. So you can put the date. Why we need to put the date? Sometimes after the walkover, you will be having the different well sketch, well components. Right? Might be squeeze, might be just the end of tubing, etc. So you might have several well sketch in one file. So yeah, you might choose which well sketch is applicable for your data later on. So that's why we have a date on the well sketch. Yeah, this is dual stream. If you have a dual stream Petronas stuff, so you might use this one, but the rest just use. Right. So something like this. This is not yet used for calculation like Nodal, but it's just for visual stuff. I mean, just visual. Okay, so caching, just click on caching, just drag it into the well sketch, the second, what you call it, blocks. You can see this one, model caching. You can have surface caching, intermediate, whatever you want. You might be able to do, but I just do this one, maybe production caching. So you might see the top one is 0 feet, the most bottom one, I don't know, what is that one? 9,000. 9,000. In a diameter is 6. I mean, it's because it's not digital calculation, just do the numbers, 7. So I click add. So you have my essence. Yeah. So if you have a tubing, you have a end of tubing, you have a packer, you have travel pack, etc. You might choose that one. Yeah. Just drag it in with the live sketch. But since this one is a monoboard, that's just simple. And I want to put the perforation in. Yeah. I'll click on that one. Board perforation. Perforation. There you go. So you don't need to type in. So simple web scan. You can save as well. Yeah, you can save. You can save a web scan file and then you just import later on if you like, so you don't need to make one by one again.
So the perforation is based on zone,
Perforation.
depths. When we import the perforation, it
It's
is
coming
based,
from the one that we type in.
yeah, from the zone, the red zone.
Yes, that's correct. Okay, so we have to do that. I put the web scan maybe on the lab, and I put my camera as well on the lab. So I have spin, cable speed, and tension I don't like to see, it's just tension. If you see the tension here, there are tension on the right side, there are tension on the left side. So it's just between down pass and up pass. When you are logging down, the tension will be higher or smaller. When you lock down,
Lower.
lower, right? So if you see down pass, it's just lower. Up pass should be the right one. So just see like that. So I don't want to say. Except if you have some increase on the tension, you might affect by your cable speed and your acceleration, then you might tend to see the tension. But otherwise, no need to look at it. Cable speed, I can put next to it, or I can put just at the end. Again, the sequence really is your call. You can call the template, but in this case, it's a mixture between mnemonic, so there's no template applicable on this case. So what do I do? It's like yesterday, I need to make it on them.
Mm.
But do we have the open home summary? No, we don't. No, we don't. Okay. So what should we do? Yeah, we should import actually, but for this case, for example, I just put up one as my reference, for example. So I go to up one, yeah, I choose up one and put it as a green, just for correlation only.
Mm.
So I know my up one is on there. So put it as a green and will be like a dark color or a black color. So then I choose one pass this time. So up one of course is on left. Then you go with the next one. To again I like to zoom in on the top part only. So I highlight with the star and I need to go to edit values to do the tab shift. That's it. Go to upgrade, tab shift. Okay, at the bottom. Up 4. And then done one is okay. Then you can done do it. You see up. And then done trade. I need to zip up. Okay. And last one. Yeah, you may see the highest the speed, the more smooth the camera, you lose the resolution. It's okay. So I just look at all of them and I've done this one, so I'll go back to up one. So I untick the reference. So I'm moving back to original color. I have my gray here. So let's make PPT. So pick nearest. Just choose one of the pressures. Then I go to F prime. And I put 6 feet. And click on block data. Apply all passes. Click OK. And we have DPD
Oh, small thing. Small thing.
6 feet.
Shit.
6 feet or 2 meters. Yeah, the smoothing, so because something like this, you have the data. So for example, this is 1,998, 1,002. So every 2 meters, so you take this number for the value, the value there, You make the delta Z TPTC and you put it in 1000. And you do for the next one 998.1 or whatever, so you move one by one. So every 2 meters. And actually, it's every 4 meters. So it's moving average. Yeah, we have DPT set. So we can put DPT set next to ground. Yeah, it's this indication if the pressure not stable for DPT set is not overlaying. Yeah, they are not really on the same reading.
If like this case, are we using the gradiometer or the PDZ?
Gradio.
Gradio. More stable.
Yeah, stable. But you can also check the value. This one is 0.45.
Yeah, quite the same.
Quite the same thing. Yeah. 0.63. Okay, this is 1 point something. 1 point. Yeah, if your difference is 0.1 or 0.2, then you might ask questions. Okay, so I'm happy with this. Click on the snapshot. I add it as PR data. L data. So we did the match offset. Rearrange the plot. So what else do we need? Okay, this one, temperature. So maximize it, so you have the spikes there. I need to get rid of the spike. So I click pick nearest. Just take one of them. Then as we did yesterday, I use able to filter.
Oh, filter.
Oh, not this morning, right? With DFCA. So what we click compute. So again, if it is spike, median. Apply. Okay, still then I need to have a bigger window. 6. Yeah, more or less okay. Maybe 7. 7. So I just put 7. Click OK and apply for all passes with the 7 window of median filter. Then I click OK. Yeah, I still have some like this one, but more or less all the strikes are gone. Yeah, so we did filter median with 7 meter moving average window. Okay.
Sorry, but if
Yes.
we have done, and then how do we like adjust or undo the filter?
We can do.
Okay.
Yeah. And then you will do redo. So if you're getting rid of spike, use median filter.
Can
Noise.
we use the undo for only for the edit
Yes.
step, or we can use if we do something wrong in the main? Let's say we have load wrong well info, so we want to undo. We can't use that, right?
It's only for editing. Yeah. That's why it's on the edit you see. Not on main. Yeah. Oh, there is a main, yeah. I don't know, you might try, yeah.
No, it's still in edit.
Oh, yeah, sorry.
Don't
We
have.
don't have it. Yes. Okay. Yes. Because you haven't filtered. Filter. Yeah, you use filter. So let's see. So pick nearest. Yes, pick nearest. Pick nearest. Click one of them. Yeah. And the browser will come up. Yes. the browser. Pick nearest. Just use pick nearest at the top, right? Just click this one. Yeah. And choose the curve and get the browser, right? And then you might go to F prime here. Oh, sorry, not F prime. Filter. Filter here or filter there. Yeah, click on that one and then you compute. You make, I did compute for 7 feet median. Then apply and okay. And then I do for all and I click okay. Yeah. Yeah, you can do that.
We can put down.
Yeah. 7 feet, sorry.
And oh,
Good. Well, yeah. Spikes median filter. Okay, so what we do next? So editing is fine, yeah.
interpretation.
Anything you want to edit? You can hide, you can delete, you know this one, yeah. You can delete or you can hide. Okay, so I'll just show you the tension. So because we don't calculate any of the tension, so I can just modify tension as I want then. Pick nearest on the tension, yellow one. Yeah, and then I can hide. So I had something like that one here. You can hide the interval, you can type in the interval, and you can put condition as well on hide. So for example, my
Hide
tension.
parts, right? Hide parts.
Yes,
Okay.
and you choose the interval and you will come up with this window. The window will pop up. And you can change the interval if you like. And also you might have some condition on that. So if my tension is higher than 400, for example, I will be hidden. So you can use some conditional. Yeah, you can have conditional. But I'm not using it just to show I can hide things here. So yeah, click OK, will be great. So gray means will not be used for calculation, but still there. If you delete, it will be deleted. I still can be undo. So this is hide. If I delete, I can just delete. I can delete. If I delete, then it's gone. Yeah. Both data will not be used, even hidden or delete, they will not be used because it's gone. And there is a fill gap. There is a fill gap. So if you have the, I don't know how big the gap is, at 220 and 261, so it's 41 feet. So if I fill gaps, a fill gap inferior than 50 feet, so I click OK, will be straight line. Just straight line between points. So fill gap. And there is an extrapolate, you can extrapolate. For example, you have the pressure gradient and then you extrapolate, you can do that. Draw line, just draw line. So pencil edit. Be careful with this one because you can make up your curve. But still, you see that you can make up.
The cooling effect.
You can make your curve. Yeah, but it's there, but you don't use it.
And your delete the
Undo.
Undo I can, I cannot. So pencil edit, yes. If you know what you're doing, that's good. But if not, don't use that. For example, if you have a spike which is not filtered out, so you know that spike, so you might just adjust. You can do that. Okay? So that's edit. We have derivative, we can have also integral. So it's not just derivative, we can have MATLAB, DLL. So if you have some equation formula, you might apply yourself. You can, yeah, it's possible. So tension, I don't like to put it in. And this one. So if I'm happy with this, I like to update my snapshot. So I click PL data, I update. Because I mean, before I don't have this DPDC, right? Now I have DPDC, so I need to update.
Play the out.
Yes, it will ask replace. Yeah, because it asks to replace. Yeah. If you don't want to replace, just click add. Yeah. So this PL data. Okay, so we see the data. We'll be calculating now. So go to main. So pressure, they are different. So maybe I use average as well. Temperature, I use the slowest down pass. Radio, I use maybe average. Spinner, I will do some calculation. So new interpretation. Yeah, we don't have the setting, so just do this one. Interpretation one. Yeah. Classical, yes, still we do classical. Spinner of V1. If you have plenty of cable speed, choose the one which is correct. Reference channels. Yeah, we don't have caliper, so I'll just put ID 6.18. Temperature, I just use dot one. Slowest down pass. Pressure, yeah, because they are changing, so maybe better to have the angles. Because we'll be using all this spinner passes now. Density, I can choose gradient. Just take all of them. There seems to be okay.
But for the temperature, when we choose the down one, the average search in up and down pass still click, right?
Yeah, that's okay.
Okay.
Yeah,
We still.
because there is no other option. This one is for station. So you either combine your pass, data versus step, or data versus time. This one is the second one. So whenever you deal with the pass, this always stick.
Average
even though we
for
can use
one data still the same, lah.
Yeah, yeah, it's just the option.
Density, all right, average.
Yeah, two will be average as well. If you choose two.
Pressure, you choose up one.
Pressure, I just choose all of them. So you can just choose one next. Or I choose all. Yeah, if you choose certain station, you don't have station, so it's not there. I did cancel because I don't want to change. Yeah, click OK. So I have my reference channels. Pressure, temperature, and drag. Then CD maths. So what you do now, go to spinner zone. Yeah.
In a zone test.
Click on spin. Or if you want to see the spinner again, so you can just click spinner zone and I can update plot layout. Go to default. And I've just seen this one, right? So just spinner, cable speed, and then shifting. And this one is vertical, so you don't really use them. I can get rid of it. So what you do, I can just do spinner maybe 8150 to 8160. Then click on spin again. 8250 to 8300. Yeah. just make this almost the same, 8390, 31. Yeah, I'm not including this. So what should I do now is just move the orange to the change of the density.
Mm.
Okay. So I have 3 yellows, I have 3 orange. I just, yeah, I just, so, okay. So we calculate now velocity, but calibrate first. So do I need to go mode 3? Yes. The font size is getting smaller than what's under 121. Okay. So let's start from bottom. Start from the bottom. The ballpoint, not very bad, yeah, that's. So just mode 3 for threshold. At the bottom, remember that there is a perforation below. So we don't have station. We should have station here, for example. There. So in that case, we know whether the bottom perf is contributing or not. But apparently we don't have it. Yeah. So assume. We need to assume. Our assumption is there is no flow from below. So if there is no flow, then the arrow has to go to 0. Both arrows at the bottom yellow. If we have the other survey, we have shut in, we have the temperature shut in, we can overlay and we check whether they are different or overlay. So if overlay, then there is no flow. If they're different, then we have something from below, and then we cannot put that one as a zero flow. But since we don't have that information, we assume this one is zero flow. So how do we do that? I need to put y mod 2 into mod 3. So I just copy threshold zone 3 and intercept into the threshold here. So I put the intercept there. So that's why my both arrows are pointing 0. Then go to the second one.
We start from the number 3, right? The last one. We start from the bottom, right?
Yes.
So
Yes.
when I click the threshold, select zone 3 and copy my values.
Correct. It's not there?
No, threshold
No.
is 0.
Okay. Because you have intercept negative, it's not negative.
Negative, not negative.
Yes. So you just maybe increase a bit on the slope to get negative. Yeah.
Increase a little.
Yeah, try to 0.054.
But it has to be a straight line,
Yes.
right? Okay.
Yeah. Not change too much. Just maybe several numbers. What's the number you have there?
I think initially it was 0.05.
Yeah, just make it 0.055.
Okay.
It works, yeah.
Um,
Still have some positive.
yeah.
What's the interval you have there? I mean, the yellow interval at the bottom.
Okay, now I think it's okay.
It's okay, yeah. So we can copy.
Mm.
So that's why you can only copy if you have intercept positive value, negative value. Otherwise, you cannot.
Okay.
Yeah.
Mm.
So it's fine. Everybody's good. Bottom one clear. Second one. So you see the red is very close to zero. So usually it's not accurate. So I like to get rid of it. Left click and tick this for regression. Yeah, it's not big change on the slope. Slightly change. That's fine. Yeah, the green one I still want to use it. So okay. So how do we put the threshold now? This is in oil. Bottom is water. If I put that number in, so the total intercept is 7. This one is 12. So the distance is larger. So I cannot put that in. And what should we do? I can just click threshold, intercept total divide by 2.
Mm.
So 50% as positive, 50% as negative with the total difference, total intercept difference. If we have shut in flow oil, then we can copy. And we don't have shut in. And then the top one. So the threshold, we don't have it. Just one slope. So I like to put threshold positive, maybe just put 10. I need to put some number higher than the second. Yeah. So I've done all the spinner slope and thresholds. Yeah,
Threshold negative.
no need.
Okay.
Why no need?
Only
Because at the
positive.
top is all positive.
Okay.
But if we put, it doesn't
No, it doesn't
really
do
matter.
anything. It doesn't help. It will directly. That's okay. Then yeah, all result, you can see all of them. Just to check the slopes, consistency between the different yellows, for example, and the threshold and the R squared. Yeah. Transition, we've done it, so we don't need to click on the second tab. Just change number, we did that one. If I'm happy with this, then click OK. That second window will pop up. Cut off, I don't know, 0.5. So then click apply or OK. Click OK, just put it. So if I 0.5. Okay, so more or less okay, 0.5. See this value here, because this is higher than 0.5. But if I put bigger number, I will lose the green one. So I don't want to get big number for the cutoff. Yeah, you can see on the spinner here at the bottom. On the upper system, they're starting move to left. This one is starting move to left. Those stone buses. Yeah. So is it really this part is TV, or maybe because of just turbulence? So we like to know the covariant examples. See, you have a very thin layer. Very thin layer. See this covering. You can switch setting on. But I like this. If it is going to zero, it's just a small comparator problem, which we have the cell break here. We don't know. Yeah, we don't know whether this one is really TV, or it's just because of the jetting. I mean, the direction is different with the spin rotation, so that's why you have on the left and then moving back to the right. Yeah, but this is pretty small, so I'm just guessing this is just because of the jetting. Yeah, if you are, I mean, want to make sure, then you can ask client whether this one is really separated reservoir, or it's just the same sands. It's a small shell break here. It's finding upward here. Just sand. Okay. So what else do we need? We have already done. So at the top, the separation is big, yeah, because you can see from the calibration, it's 995, yeah. So you might see the variation is large. If you click on the result, this one is 997, this is 995. So you see this bit smaller R square, so you have the separation more on the top. Yeah, but you might see the stone passes. You might ignore the green, for examples, but that one you have more separation. So just use all of them at the moment. And then we have already PVT. So what PVT we use is oil and gas and oil, right? Saturated oil, no water. What's the value? RS 1100. Oil 38 API 1100.
0.7.
Oil 31. You go to oil, change to API, make it 35 API.
38.
The gas gravity is 0.7, so it don't change. Gas gravity is default, RS oil gravity in
0.7.
yeah, 38 API and 1100. Oh, sorry, I need to. I did 35, sorry. So yeah, I just change the RS and gravity 38 API.
For oil, for gas, what do we change?
It's the same 0.7.
0.7.
Don't change.
Okay.
Specific gravity.
And if you are okay, click Okay.
For the below info, all constraint.
We do it later on.
Okay.
For example, we don't have that one. We just have this thing, for
Okay.
examples. Then we see what's the difference.
Every time we don't have. Most of the
For the
time we don't
first
have.
step, do we have to change anything?
Which that?
The first one?
That one?
So we
No,
just
no.
put
1100.
1100 unit same.
Yes.
Okay.
This is just a display, so it doesn't matter.
Okay.
Yeah, you don't include water because we don't have water. So let's go for red bottle, green bottle. Red bottle is the same, green bottle it change to API 38, that's it. Okay. So just the two numbers.
Okay.
So then hiccup. So hiccup, no, I put on the second option.
Same as
Yeah, because we have spinners on different depths between birth. So I can do that one. I can update plot layout as well. Click OK. So I have matches, tracks, and also inflow zones. So I do that things. And then we have that one. Just make sure that in front of the gray, the reference channel are good and also velocity math and density math. They should be in a stable condition. Otherwise, you might need to change the depth. Yeah. So click rates. And now we are in liquid gas because we define gas water, sorry, gas oil. So you might have different single phase liquid gas.
Can we choose the correlation? Yes.
Yes, you can. So I'll show you. So click OK. OK again. That's it. But we skip some of the step. So we let go back to the steps. So click on rates. So we have spin and graph. Yeah, two variables. So the error is good, 0. Let's go to plot. Bottom one here is density of gas and density of oil. Where is it coming? This value.
Parameters.
Yeah.
Mhm.
So that's PVD. 0.665, 0.13. So it's different between the zone. Yeah. Because different PNT. Okay. So make sure the number more or less good. Then we have the endpoints, two endpoints from PVD density. And then we have a gradient density here, which is coming from which number? 0.4626. That's fine. Measure, which is the dash line here. So Emerald will try to make the dot line to be the same with the dash. And then if it is fit, then we'll go to the Doppler. So you see the intersect with the Doppler and you draw the vertical line and you will see from 0 to this line is Q oil. From that one to the maximum is Q gas. So for example, if I move this one over there. Yeah.
Just slide by.
Yeah. So you can see that the reading is still 0.46, right? But my match is 0.49. My radio reading is this one, but my match is 4.9, almost 0.5. So it's not matching. The error is big, 8%. Yeah. So what Emerald do for this nonlinear regression is try to match the logic to the test.
Mm.
Yeah. You can also do improve. Improve means recalculate. So if I click improve, recalculate in all zones at the same time. But improve is only that zone. Click improve, it's going down. And then we'll try to intersect with the dark curve. You will be having this solution line. If I change this one, after slightly different.
Mm-hmm.
So I need to improve again. When I improve, look at the number is moved. If I change to Hagedorn block, I improve, I get good match, and you have a different composition again now. Yeah. So what is this triangle and the squares?
Triangle and square.
The triangle is the total Q from the surface. Q oil, Q gas all together convert to the top calculations on PMT, which is this PMT, and showed up as a down arrow, down triangle. So our calculation is higher than the surface rate, the total. Yeah, you can see here as well. This is the surface rate, this is our total. So our total is higher. If it is fixed, then this triangle will be the same as this maximum test line. This number you can only see on the top calculation. The second one you don't see it. The top one is the one. And the square one is the solution for different correlation. So the intersect here will be at the square. So you might see the difference of the position of the square. So you might see different radio to get the same composition as surface 2700 and 4.5 million scope. So you might see this has to be at this intersect. And in that case, your composition is the same with the surface composition. But our composition is higher. So I have more component of oil than the surface. That's why it's not. So if it is matching, then the square will be on the intersect. So that's and on the second one, so remember Mahmoud, this one that I mentioned, this one, straight line. So usually if the density is 0.3,
Okay.
I will not use this Garnet Ross. I will use the one that has this one, so probably the Hagedorn. It says more continuous. Oh, not Hagedorn, this one is Stanford block. No, it's not Stanford block. Something like this. Yeah. So it's 0.3, then I have some numbers. Not very straight vertical line. Yeah. So this is the choice you have for the different correlation. If I choose the Doppler, I need to improve again. Then I will have a different composition, oil and gas. Yeah. Then error is zero, but always good to go to plot. Yeah, just not stop because you have zero error. But please always go to plot and look at the match here or the solution. Is it really good or not? Because if you are in, for example, I use Becks and Brills. Yeah, I use Becks and Brills. So you see there are three solutions here. So if I have something like this, I will not use back cycle. Because if I use back and drill and just look at on the table, if I click improve, I have match. If I move that one on the left, improve, I have another match. And you have just between that one, I have three matches. So which one is good? You need to go to plot to see. Yeah. So maybe that one. Yeah. This is more make sense comparing the surface. But yeah, I would rather not using this one for this correlation. Try to see only the one intersect, not three or two.
From here, can we tell whether it's in a mixed flow, sluggish? Can we tell the flow of this bubble?
Yes, you got that one. This one.
Intermittent.
And this is the statement.
Mm.
So you calculate directly. If you change the correlation, you can see different sliver, different regime. So you know directly what that.
Yeah, excellent. So during the calculation, yeah, so I think that we need some adjustment. For example, if the client they need to map the surface. So the one thing is that we can buy the I think that it's the slip page, yeah. Okay, by the by using that by using the correlation.
Charge dapat.
You want to perfect match.
Yeah.
Uh,
Yeah. So normally I say that is changing the
yeah, you can do that one.
yeah.
If you have the different composition, you can slide in, slide out, but you will be having some error
yeah.
moving away from the correlation. Or you can try to change correlation. Yeah.
We can change the correlation or we can change the I call that the heavy.
I would rather just change correlation. Yeah, you can see this one. So if my oil is too big, I need to get maybe the green one here, oscilloscope here. So something like that. So then I still having a good match. Because you will be seeing on the density match. Yeah.
We got the two kinds. One is you change the correlation. The other you change the
Yeah, if you change this one, for example, like this, right?
yeah.
If I slide, yeah, if I slide something, if I click on that one, see, I'm moving away.
Mm.
So the client maybe don't like to see this. So I prefer to use this correlation and then this one still moving, I mean still matching, but the composition is more or less similar with the surface. Yeah. Or you have the option here, the surface match. But usually I don't like that one. But if your client insists, so you can do. Yeah, you can do. So basically you have two components here. Coefficient multiplier and the slippage multiplier. The principle is something like this. It's simple, right? So you have this is the surface composition, right? This is the surface. Q oil, Q gas. But you have this your spinner composition, for example. Q oil, Q gas. Yeah. So this is your spinner. This is your surface. So we need to have two components, two variable. First, this is the same, is zero, and this is the total. Yeah, we need to convert using this one, VPGN multiplier, the first one, VPGN multiplier. So multiply, and then the second one is the slippage multiplier, which is that one. So first is the total, which use VPGN multiplier, And the second one, use the slippage to get the composition correct as the surface. So there are two variables. First, the total. Second is the composition. So that's why you have VPGF multiplier. This one is VPGF multiplier. And this is slippage multiplier.